This is Properties of Matter. We are continuing Unit 1.3, which talks about matter and change, and so that's exactly what we are going to talk about. Properties of matter and how does matter change, which is good because that means we can move on to chemical reactions and looking at more of the mechanics of how matter changes. So, first of all, here are your objectives that you are being expected to know and learn by the end of this unit. And so objective 1 is basically that you, the learner, will be able to apply the definition of extensive or intensive properties by classifying a property as either intensive or extensive. And the second one, you will be able to classify a property as either physical or chemical. And then last, if a change happens to matter, you need to be able to classify it as physical change or a chemical change. So let's start talking about that. So first we have properties of matter, and there's two properties. There's a physical property or a chemical property. All properties of a substance will fall under these two categories. So let's look at a physical property. A physical property is any attribute of a substance that can be observed or measured without changing its chemical composition. That means if I can measure it without changing what it actually is made of, then it's a physical property. So here's some examples of physical properties. The color, the density, how hard an object is or how hard an element or any material is, and the temperature are all physical properties. I can measure all of these without actually changing the chemical makeup of a material. The color, obviously, I just look at. Density would be measuring the mass and the volume and then dividing. Hardness is, well, you dent it and then you measure how deep the depression is, but I'm not actually changing it. I'm making a dent, but it's not changing how the atoms work. And then temperature, I'm just measuring with the thermometer. Okay, and so that would be a physical, and so a chemical property would be any property that actually is going to create a new substance, or the ability of a substance to make another one through a chemical reaction. So here's some chemical properties. Rusting. Rusting is making a new substance because it is combining with oxygen to create a new substance. Combustion and explosion as a chemical reaction, and inflammability is again just like combustion, is burning. So any property or any ability of something to make a new element is identified as a chemical property because it involves a chemical reaction. And then so how this applies is, you remember a mixture is any combination of two or more things that are not chemically bonded. So that means we can separate a mixture based on their physical properties, since they are not chemically bonded but physically mixed together. So physical properties like size, magnetism, color, or even boiling point, we can use those to separate a mixture. So if we have a mixture of sand and gravel, let's say at the beach, and I want to separate the two, I can use what we call a sieve, which is like the little, sort of like the little bowl that you use to separate noodles from hot water, and also known as a sifter. But I can use that to separate gravel from sand as the sand falls through the small holes in the sieve. And so I can also separate a mixture by magnetism. If I have iron and sand together, obviously the magnet is going to pick up the iron and not the sand. And even like a crane of a car is going to pick up a car. You can separate cars from another material. Also, you can separate them by color. Obviously, if I have a bag of M&Ms, you can separate all the brown ones from the orange ones, from the yellow ones, because you can visually see the different colors. And like a bunch of rocks, you can pick out individually which colors go with which, and that would be separating a mixture. And then lastly, you have distillation is another example. And so that would be separating by different boiling points. By heating something up to the boiling point and letting it leave, you can separate it from mixture. Like with salt water, if I evaporate and boil off all the water, then I'm left with salt, and that is separating the homogeneous mixture of salt and water. So another level of classifying properties, we have physical and chemical, and then we have intensive and extensive. An intensive property is any property that does not depend on the size or amount of a sample. So that means no matter how much of something I have, this property will not change. Remember that in front of a word usually means not. So intensive means it is not dependent on how much of something I have. Remember on your test the question about density. If I chop a block of wood in half, the density of each half does not change. Temperature does also not depend on how much of something I have. Melting point, specific heat, color. If I break a board in half, the color is not going to change. The colors will stay the same. So color is another intensive property. It does not depend on how much I have. So obviously, extensive is going to be the opposite. So a physical property that does depend on how much I have is extensive. And so mass, if I have a bigger block than a smaller block, it's going to have more mass. So it depends on how much I have, therefore it is extensive. Volume is also like that. So is heat. A small piece of iron that is hot is not going to have as much heat as a large block of iron. And it's different than temperature. It's going to be a little tricky, and we'll talk more about that in class, the difference between heat and temperature. But heat is extensive and temperature is intensive. And then lastly, weight. Obviously, if I have more of something, then it will weigh more. So weight is extensive as well. So now that we know about properties, sometimes those properties change a lot. And those changes in any matter, anything that has mass, everything in the universe, if something changes, it is always either a physical change or a chemical change. So a physical change is any change which alters a material without changing its chemical composition. So if I change it and the chemical structure stays the same, it is a physical change. So let's look at some examples. So a phase change going from gas to liquid to solid, that is not changing the chemistry, the chemical structure, so it is a physical change. Dissolving something and crushing something, these are all physical changes. The molecular structure stays the same. So dry ice sublimation. Remember that sublimation is going directly from a solid to a gas. So dry ice, changing a phase, that is a physical change. It starts out as carbon dioxide and it ends as carbon dioxide, so it is a physical change. Water boiling, same thing. It starts off as water and ends up as steam, which is still H2O. So it never changes its chemical composition, so it is a physical change. Also salt dissolving. In the first picture, you have salt being added to water and it dissolves. And even though it seems like a chemical change because it disappears, if I evaporate all the water off like in the second picture, I'm left back with salt. So I start with salt and I end with salt. Therefore, There was a physical change because I did not alter the chemical composition. It stayed the same before and after. And then thermal pollution is another example of physical change because all that means is increasing the temperature of something. So like the giant nuclear cooling towers, all that's putting out is steam, and adding heat to a pond, the thermal pollution of adding heat from nuclear reactors, that is a physical change because you are increasing the temperature, but you are not changing the chemistry of anything. The atoms are all staying the same, just bonded as before. So that was a physical change, and so a chemical change is going to be a change that does change the actual chemical bonding of a substance, which means if the bonds change, that also means that you are creating new substances. So an example would be rusting of iron. That's taking a metal, an iron, and bonding it with oxygen. So you start out with iron, you end with rust, which is iron oxide. So those are changing a substance. Photosynthesis is another change. You start off with sunlight, carbon dioxide, water, and you chemically change them into new molecules, being oxygen and glucose. You might remember that from chemistry. So photosynthesis is a chemical change because it changes into new substances. Digestion of food. For you take in bread, meat, and butter, and your body chemically changes those into new molecules, and those would be glucose, amino acids, fatty acids. So you are chemically changing food into those, and then remember your body changes those into ATP. So that is another chemical change on top of that. And then combustion of gas. So burning a stove, when you turn on your car and you burn gas, or if you're going to have a little cookout and you got your little fancy grill there, all of that is taking gas and then you are burning it, which is actually changing into a new substance, which would be carbon dioxide and water, and we'll find that out later in the spring. So when I give you a question or a scenario and I ask you, is this a chemical or a physical change? Here's some clues to help you figure out whether it is a chemical or physical change. Clue number 1, is energy being absorbed or given off? That's a big clue. 2, is it changing color or odor? Is it giving off a smell? Number 3, is it making gas, production of gas, or is it forming a solid from a liquid? That would be another clue. And then the last clue is if it's not easily reversible, it's probably a chemical change. Like rust. After a car rusts, it is not easy to turn it back. So it's not easily reversible, and that's a big clue that when something rusts, oh, it's a chemical change. And also you can apply the other ones. Rust does change the color, and there's not technically a production of a gas or solid, but it changes color and it's not easily reversible. So that's 2 clues that rust is actually a chemical change. So on Monday, we will go over examples and we are going to work with this. So you are responsible for writing down the definitions, and then we are going to talk more about this on Monday. So thanks, and that was Chemical Changes with Mr. Bell. Have a good evening. Good night.